So now we are going to take up the topic that is the reaction mechanism. Right. So what happens, like how the reaction take place, we will be studying in that, like what probably force the reactant to undergo a change. So we are going to study everything in that, in this some basic concepts of organic chemistry. So actually what happened, like when we talk about reaction mechanism, so whenever you can say that whenever we react something with an attacking reagent, like I will just show you with an example. Suppose I have something which is going to react. I am going to call this something as substrate. Right. So this is going to react with some attacking reagent. It is going to attack some, or you can say it is being attacked by a attacking reagent. What happens when they react? They always form an intermediate. Before forming a product, we get an intermediate. And after that, there is something that goes off. That means we have a living group. And as a result, we get the product, the final product, along with the byproducts also. So I will just explain you with an example that how the reaction take place. So let's say that this is our reactant. Let's say this is our reactant. So this is actually a substrate. We will be calling it as substrate. It will be attacked by the attacking reagent, right. So this is my attacking reagent. Say I have this attacking reagent which has the extra pair of lone pair. So at this moment we are not considering any type of attacking reagent. We have only a general term, that is the attacking reagent. That's it. So what happens when they both react with each other? What they form actually? They form like this. The bond formation is like this. This bond actually breaks up then only because it is going to add something into it. So we get this. Right. This is something called as intermediate. This is something called as intermediate. Now this intermediate, something will go off and it will form the product, and what is that which is going to leave? It is the X. So minus X group will be leaving. So this is our leaving group, and what we get as a result? We get bond again becomes double, and we have this. So this is our final product. So according to this, the reaction, I think you got it, that how it take place. We have a substrate, this is being attacked by attacking reagent, it gets attached and somehow it forms the intermediate, but as long as the stability is concerned, this intermediate is actually unstable. It is actually unstable and it lasts only for short span of time. It lasts for short span of time. Then something always goes off. So this is our living group, and as a result we get the product. So whenever somebody asks you about that, how basically the reaction take place, you will say that we have a substrate, it is attacked by an attacking reagent and it leads to formation of unstable, you can say a product, or intermediate will be the correct word. It will lead to formation of the intermediate which lasts only for a short span of time as it is unstable. Then something goes off and we get our final product. This is what is the reaction mechanism. Now if we talk about all the things which are actually included, because attacking reagents can be of many types, intermediates can be of many types, living group can be of many types, and even on the, you can say, nature of product we have different kinds. So we will be taking all this into consideration because we are starting with the very basic. We are just making you familiar with the very basic, so that you should know that actually what are those, you can say, the names which are taken in a reaction, which you get, sometimes you get confused for that. So if we talk about this reaction, so it includes the substrate, that is our reactant, you can say, to which the attacking reagent will attack. We will definitely include the attacking reagent, it is very important, and we have 3 different attacking reagents. It can be electrophile, it can be nucleophile, it can be free radical. We will discuss all those things, that what are they actually. Next we have is the intermediate. I told you because it leads to the formation of the product, that is the intermediate actually, which is very unstable. And there are types of intermediate. carbocations, carboanions, again free radicals, and we have carbenes. This is B. And then what we get is, we get the living group, we include the living group, the group that goes off actually, and then we have the product. And also we know that when the, you can say when that react, it forms an intermediate, and here the bond gets cleaved actually. So we have a type of bond cleavage also, because we know that for a reaction to occur, there is a specific condition, a compulsory condition which has to take place, and that is something called as bond cleavage. And depending upon that, we have two kinds of bond cleavage. One is homolytic and other is heterolytic. Right, so this is the types of bond cleavage. So I think it's clear that the reaction mechanism always include a substrate, attacking reagent, can be electrophile, can be nucleophile, can be free radical, intermediate, can be carbocation, carboanion, free radical, carbene. There is always a living group and we have a product, and obviously the bond cleavage has to be there. So bond cleavage, depending upon that how the cleavage is taking place, we have two types, that is the homolytic and the heterolytic. So before we discuss everything, like we or you can say we start with the type of attacking reagent or intermediate, we will first look for the bond cleavage, because we know that this is the compulsory condition for the reaction to occur, that is the bond must cleave, because when the bond will not cleave, we won't get the product, right, because the reaction always includes the breaking and the forming of bonds, right. So we need a bond cleavage. So first we will start with that, what kind of bond cleavage do we see? So we have the bond cleavage of two types. One is homolytic, other is heterolytic. So we have two kinds of bond cleavage, homolytic and heterolytic. So what is that actually? Homolytic one is the one in which each atom takes away one electron of shared pair. Let me explain you how. Suppose I have this AB, there is a bond between AB, right. I need to cleave it. So when I will cleave it, if the cleavage occur this way, that you can say that one out of the shared pair, one electron is being taken by one and the other is taken by the other. So that means equal, you can say these living groups, when they just cleave, they take equal number of electrons with them. Or we can say the atom which with the unpaired of electron is as a result of homolytic fission, right. And you know that what, there is a special name for these, an atom with an unpaired electron, they are called as free radicals. So we can say that homolytic fission is the one in which each atom, like the bond cleaved in such a way, or you can say the bond fission occur in such a way that each atom takes away the one electron of the shared pair. So it also takes the one electron and it also takes the one electron. So that means they take the equal number of electrons with them when the bond is cleaved. So as you can see that this is A with an unpaired electron, B with an unpaired electron. So this is actually a free radical. Likewise, we talk of heterolytic one. So the heterolytic one is that in which the bond cleave in such a way that one atom takes away both the electron of shared pair and the other atom takes nothing along. It does not take any electron. For example, I have this again a type of this bond form. The cleavage will be something like that. Let us say the bond gets cleaved like that. So as a result, the B will take all the two electrons along with that and leaving behind the A, which is deprived of any electron, So it's like that. So as a result, what happens, and one more thing, it can be cleaved in the same way. Don't think like that I am being partial and I am just giving the electrons along with B. It's not any hard fire rule. So what happens, it can be cleaved this way also. That means we can have this thing that A takes both the electron and B is deprived of any electron. So what happens when they just when the bond gets cleaved in such a way that whether A takes both the electrons or B take both the electrons, we will result in the formation of the one atom which is deprived of electron, and the one which is deprived of electron acquires a positive charge, right, and the one which takes away the electron has more electron density, so it will acquire a negative charge, right. So here in this case, because A took both the electrons, so it will acquire a negative charge and B will acquire a positive charge. And you know that the atom with positive charge is something called as carbocation, is called as carbocation, and the one with negative charge is called as carboanion. So this is carbon with positive charge and this is carbon with negative charge, or you can say a group with positive charge, a group with negative charge. So as a result of heterolytic fission, what do we get? We get the like the bond cleaved in such a way that both the electrons are taken away by this one atom, another is deprived of that. So as a result, the one which takes the electron, both the electrons with it, is called as carboanion, and the one which is deprived of electron acquires a positive charge and it is something called as carbocation. So this is our fission, right. So we have already done the bond cleavage, that how the type of bond cleavage we can do is, or we can show is, so it is basically a homolytic or the heterolytic. Just looking at this, that if the shared pair is equally distributed between the atoms when it is cleaved, then it is homolytic. If it is not symmetrically distributed or unsymmetrical distribution of electrons between the two atoms, then it is a heterolytic one, right. So homolytic results in the formation of free radical, you should know that, the atom with unpaired of electron, and the heterolytic one result in the formation of carbocation, that is the one with the positive charge and the one with the negative charge. So now we will be discussing what are those, or you can say we will be discussing the attacking reagent first, then we will discuss the intermediate. So just look at the board, that how the types of what types of attacking reagent does a substrate encounter actually.